Hi students, in this session we will be discussing about the second way of creating a valid XML document, that is called as XML schema, and also we will discuss about some mechanisms for querying an XML document. So first of all we will see what is XML schema. As I was describing in the previous session, XML schema is a mechanism used for creating a valid XML document. So we have seen XML DTD, which is one of the mechanism, and we have also seen some of the drawbacks of using XML DTD. So in order to avoid some drawbacks of XML DTD, we are following XML schema. So the primary advantage of XML schema is it is following the same syntax pattern of basic XML document. Okay, so the main advantage of XML schema is it is following the same syntax of XML document. So if they are following the same syntax, the thing is we can follow the XML schema can also follow the same processing. The processor for compiling or for processing that document that is used for XML document can also be applied for XML schema also. So we don't actually require some additional processes for this XML schema. That is the major reason why we are following the XML schema for creating a valid XML document. So we will see one XML schema. We will see one XML schema file, that is XML schema document, which is for a company database. So it is a very large code, but you can simply follow some of the portions so that we can understand the different elements present in this XML schema. It's a very simple thing only. We don't need to write all these statements. So we will select some of the elements and we can only follow that, so that we can completely follow the XML schema. So here we will see different components of this XML schema and what is the meaning and how it is being represented in XML schema format. So as you know, it is following the same XML syntax. So there will be a starting tag, end tag, etc., etc. All these things are followed as in an XML document. Okay, so here you can see the first statement as XML $XML version is equal to 1.0. then other attribute, we are using one attribute like encoding is equal to UTF-8, that is the encoding format followed in XML document. If you want to have standalone, where we can use standalone is equal to yes. Okay, so this is the first statement, that is the XML declaration or XML declaration itself. So next statement is very important. Next statement is very important. You can directly look into this. Here left angle bracket XSD colon schema, that is the name of the tag, XSD colon schema. Then you can see an attribute XML NS colon XSD is equal to, we can see one URL, then right angle bracket. So what is this XSD schema? So XSD schema is a tag for creating a schema. Which schema it is going to follow. So XSD means schema description, XML schema description. So XSD colon schema. XML NS means XML namespace colon XSD is equal to a URL. So what is this URL? Within this w3.org 2001 site, we are having a predefined XML schema. That location is already available, and we are going to follow those contents, all the elements that are present in this XML schema under this w3.org. Then this URL is assigned to SSD, which is the name given for this particular URL, because all the descriptions are available within this URL only. So, and name it is assigned to, so that is why XML namespace, we are providing a name SSD to which this URL is assigned. So that is why all the following tags will be written with an XSD colon, the name of the element. So XSD colon, here it is schema. So from here itself we are starting utilization of this SSD colon schema, then XML namespace for assigning the URL into a given variable. Here we have used XSD. I hope this is also clear. So XML schema consists of the different rules to be followed for the different elements present in XML schema. Now following all the tags will be starting with XSD by this name, so that it will be following the contents of this particular URL. Now you can see one of the representation of tag, that is XSD colon annotation. This is the starting tag of annotation, this is the end tag of annotation. In between you can see SSD colon documentation. So this area annotation is used for writing the different documentation or comment part. So under annotation I am using another tag, that is SSD colon document. So all these things are actually under XML schema. SSD colon documentation space XML colon lang is equal to en, that is en means English. We are setting the language of this XML document as English. So SSD documentation, by using the language English, I am writing the statements company schema element approach prepared by Babak Hojabri. This is the comment. Then end of SSD documentation, which is enclosed within SSD annotation start tag and SSD annotation end tag. So XML declaration, schema assignment, giving a name for schema description. Then annotation portion is used for writing all the comment portion of the following XML schema. Then we can see XSD element, XSD colon element. Element is another member of this particular XML schema with an attribute name is equal to company. So I am going to describe company now. Company is an attribute or an element of that particular XML document. So I am going to describe that company. So the description is done by SSD colon element name is equal to company. So following statements are description of company. Now under that the first statement is XSD colon complex type. That means this company is following a complex type. SSD colon complex type. Now after that, so these are continuation. All these are actually under this SSD element name is equal to company. Now SSD colon sequence. The following things are in a sequential order. That means company consists of a complex type structure with some sequences of elements followed. So what are those sequences of elements? First one is SSD element name is equal to department. So company consists of one element department. Its type is equal to department and minimum occurrence is 0 and maximum occurrence is unbounded. So in DTD we are using plus star question mark. Here it is directly by using attribute names like min occurs and max occurs. Minimum 3 times or maximum any number of times. This department followed by company. I hope it is clear. Now under company we are having department, then we are having SSD colon element name is equal to employee. Now we are having the second element employee under company. Its type is employee type, and minimum occurrence is 0 and maximum occurrence is unbounded, similar to the previous one. So under company we are having a department and an employee element. Now under this element employee I am writing SSD unique. So along with this employee I am writing SSD colon unique name is equal to dependent name unique. So I am going to set a unique name, the name that is dependent name unique is the name of the or the attribute which can be considered as a unique value. That means a particular position, particular element present under this employee must be of unique value. The value cannot be repeated, as we are using unique in SQL. Unique, but primary key is different, unique is different. So I am setting a name for that. For a unique value I am setting a name, dependent name unique. This is the name assigned here. And how we are going to set that, which is being selected as unique. So SSD colon selector, I am using selector from this XML schema. By using selector I am using a querying of XML, that is XPath is equal to, I need to provide the path of that employee dependent slash. That means under employee we are having employee dependent attribute available and the value of that. So under employee dependent, which one? The field is SSD field, XPath is equal to dependent name. So the dependent name present under the employee is a unique attribute. We are setting that as unique. Then close this SSD unique. So this is a paired tag. So here you can see SSD element department. We are not having much details on that, but SSD element employee is having some description like adding unique. Then this SSD element is being closed here. Then again we are having one more element, that is SSD element name is equal to project, type is equal to project, min occurs 0 and maximum occurs unbounded. So what about this project? This project is again what? Sorry, before that this is being closed. SSD complex type, SSD sequence. This SSD sequence is being closed. Then SSD complex type is also being closed. So this is the primary area. So company, so these are the conditions which is already defined within this XML schema. It is a separate document that is following almost similar to XML syntax with some specific condition. So the primary conditions are like, it is having an element called company, root element, which is a complex type, which is further divided into a sequence of elements like department, employee and project. The department properties, employee properties, employee is being added with a unique attribute, then project properties, then sequence ended, complex type ended. So outline is clear, a company with department, employee and project. Outer portion is now cleared. Now next one, after that I am starting describing all other elements. Now SSD complex type only, right, that is being closed. Then company itself, under that I am going to explain SSD unique. So for separate elements of each of these separate portion, SSD unique, so I will be setting a unique value, that is name is equal to department name unique. I want to set some element of department as unique. So this is the name assigned for that particular condition. SSD selector XPath is equal to department. From department, the field SSD field XPath is equal to department name field is set as a unique value. So that unique is being set. Then another, so we will see little faster. Here also you can see a unique name is set for project name. Then next one, this is different. Next one you can see this portion, SSD:key. So these two are unique values. Now next one is key. Key is used for setting primary key. SSD:key name is equal to project number key, which is the name assigned internally. Then SSD selector XPath from project number is considered as a primary key. Then here you can see from department number is considered as key. Then again here from employee SSN is considered as primary key. Then next one is a foreign key representation, SSD:keyref. Keyref means a foreign key representation. Now foreign key means what? One attribute of one relation is referred or depending on the attribute of another relation, that is foreign key. So keyref name is equal to department manager SSN keyref, that is a name assigned internally. Refer is equal to employee SSN key. Employee SSN key is the reference. Refer employee SSN key. Now which field? Department manager SSN. So employee SSN key is referred by department manager SSN. They are actually related. Okay, so department manager SSN will be depending on employee SSN key. That is already created here. Employee SSN key, this one. So department manager SSN is depending on another key, that is employee SSN key. So this name is followed here. What is this name? Employee SSN key. What is that? That is the name given for the key of employee SSN. That is employee relation, employee SSN. Key is given a name, employee SSN key. Now here department manager SSN is depending on that employee SSN key. Similarly, you can see another keyref that is given a name, which is referred to department number key. Department number key is department number key. This is department number key, this one. Now which one is depending on that? Employee department number is depending on the department number key. So employee department will be depending on the department number. So an employee will be belonging to the department number, which is already there in department relation. That is the meaning. Similarly, you can see another keyref, employee supervisor SSN keyref, that is employee SSN key and employee supervisor SSN. These two are referred. Then one more foreign key, department number key, project department number, they are being referred. Then another keyref, project worker SSN keyref and project worker. The SSN of employee SSN and the project worker. These two are actually being referred by using foreign key concept. So next one, keyref, again project number key and project number, they are also being referred each other. Then finally we are closing SSD element. So where we started SSD element, SSD element here, that is the company, that is being closed here. So we have seen SSD element company with complex type with sequence of these three elements in general. Then after that it is representing all the unique and keyref foreign key attributes separately by providing the conditions based on the syntaxes given in this SSD unique, SSD key, SSD keyref, etc. Then later again further description for each of the different types. We are giving further names for getting the further end value. SSD complex type name is equal to department. So for description of department, we are again department is again SSD sequence of elements with SSD element name is equal to department name, type is equal to SSD string, which is following string type. Then SSD element name is equal to department number, type is string. Department manager assistant string. Department manager start date SSD colon date, it is following date type. Then department location, which is also following string type. So this area is about describing the complex type department with the final end value. Now similarly, complex type employee, again SSD sequence with all these values. With all these values, element employee name, employee SSN string. So employee name type is given as name, so we'll be further describing name later. Okay, so employee name type is name. Then employee SSN string. Then employee set string, employee salary unsigned integer. Then employee birthday date, employee department number string, supervisor assistant string, employee address, which is again given a different type address. So this name that is to be described separately below, this address that is to be described separately below. Then a relationship is given, employee work zone. Work zone is the type, minimum occur once, maximum occur unbounded. Similarly, employee dependent, min occurs 0, max occurs unbounded. So this is about employee and its final value and its type. It is just like providing PC data along with each individual attribute therein, XML DTD. Then another next one is SSD complex type project. This is the project area where project name string, project number string, project location string, department number string, then project worker with min occurs 1, maximum unbounded. Then dependent name string, dependent sets, dependent birth date, dependent relationship. Then next complex type address. So here it was address that is being specified here. Name, number, string, street string, city string, state string. So this area address type is equal to address will be directly following this particular format. Complex type will be followed. Then name, which was already mentioned here, this name again that is being defined separately. SSD complex type name equal to name, which is of sequence of first name string, middle name string, last name string. Then complex type worker is defined here, worker with sequence of SSN string, hours, float. Then work zone relationship is specified here, so sequence of project number with string and hours with a float value. Then finally SSD schema is being ended. That was the starting of this XML schema. So it's a very long XML schema, but you can simply write a very simple, you can write it like element name equal to company, just followed by SSD sequence department alone. Just write that department alone, then write the details of all the details related to department alone. Then you can also write complex type department, just provide the details of department alone and its further details. Okay, so this is an example of XML schema which exactly follows the syntax of XML document. Only thing is it is taking the schema that is already defined under w3.org and that is being assigned to some schema description name, and this description name is used for providing all the start tag and end tag of all the elements present in this XML schema. So I will once again describe what are the contents of this XML schema. So I have already described with that document example schema descriptions and XML namespaces. So first statement. So it is necessary to identify the specific set of XML schema language elements by a file stored at a website location. So in order to identify the set of rules, the schema language elements, from where we are getting that. So we need to specify the URL of that particular website. So that is why we are using the second line as the file used with http://www.w3.org with this URL. So this definition is called as XML namespace, assigning this into a variable called as SSD, that is called as XML namespace. So the file name is assigned to the variable SSD, right, using the attribute name XML namespace, and this variable is used as a prefix to all the remaining XML schema tags. We have already seen that. Then annotations. So the first portion was annotation, which describes the documentation. So annotations or a documentation or the language used for the XML schema is given in this particular area. So SSD colon annotation, like SSD colon documentation, all these are used for providing comments and other description of the XML document. Similarly, the XML colon lang is used to specify the language of the documentation. That is, here in this example we are using EN, which is representing English language. Then elements and types. So we specify the root element, then within the XML schema the name attribute of SSD element tag specifies the element name, which is called company, as the root in the given example. Similarly, the structure of that company is specified by SSD colon complex type, that is to be further defined separately. Then first level elements, that is the employee, department and project. These are the first level elements of company database that was specified by using SSD complex type and SSD sequence, employee, department and project. If a tag has only only attributes and no further sub elements, then it can be ended with a backslash right angle, so that it is termed as empty element. If you are not having any further sub elements available, it can be ended with a slash and right angle bracket. It is called as an empty tag or empty element. Now specifying element type and minimum and maximum occurrences. So if we specify a type attribute in an SSD element, means that the structure of the element will be described separately. So if the type is given separately by a name, its structure must be separately defined in the XML document, XML schema document, by using SSD complex type element. There we can specify the min number of occurrence and max number of occurrences by providing the lower and upper bounds like 0, 1 or unbounded. Then key specification can be done by using that is the various keys like primary keys and foreign keys by using SSD key and SSD key ref element. So when specifying a foreign key, the attribute referred to the SSD key ref tag specifies the referenced primary key, whereas the tag SSD selector and SSD field is used to select the element type, specify the referencing element type and foreign key. Then specifying the structures of complex elements via complex types. There we can use SSD colon complex type. Under that we can specify a sequence of sub elements like the attributes that are used in normal databases. Now each element is given a name and type with attribute name and type of SSD element. We can also specify min occurrences and max occurrences for all these elements by using the different values like 0, unbounded, etc. Then how we can represent composite attributes. Composite attributes can be represented by using for example address, name, worker, all these are composite attributes which are defined separately. So we can directly use that within the parent elements, and separately we can define address, name and workers in a different area. So that is all about XML schema general description. One example company was given and the description of XML schema was also being specified. Now we will see another hierarchical tree view with course as the root element. Another example. So how these members are actually related. So under course we can see two attributes, number and name, and under course we are having a section, and each section will be having number, year and quarter, and some students. With each session we will be having, so you can see course with attributes and another element, and section with some attributes and another element, and this element student is again having some other attributes. So how it can be represented by using XML schema for this simple tree structure like course, section and student. It's very simple. SSD element name is equal to root, SSD sequence, SSD element name is equal to course, so course is the first one, course, min occurs 0, max occurs unbounded, which is of a sequence of element, first element C name, next element C number, then session, then session is again, so this is session, section is again a sequence, SSD sequence of elements, section number, year, quarter and student. Then student is again a sequence of SSN, SName, class, grade, right? Then SSD sequence, this one is being closed, SSD element is being closed, SSD sequence is being closed, SSD element is being closed, SSD sequence is being closed, SSD element is being closed, this SSD sequence, then SSD element. So this tree model can be converted into an XML schema format. It's a very simple concept only. So here course is an element with attributes number, name and another element, that is session. Then session is again with number, year, quarter attributes and another element student, which is further divided into SSN, name, class and grade. So that is all about XML schema. The second way of making an XML document a valid one. So XML schema is having a different way of representing the properties of elements used in XML document, and whichever XML document is following XML schema must strictly follow the rules specified within the XML schema, so that the XML document can be converted as a valid XML document. So next part we will discuss about some of the querying, XML querying. So if you represent this XML in XML database format, how we can actually access the content from XML database. So there are two types of XML querying. So first one is XPath. The method is XPath. So what is this XPath? It is an expression that returns a collection of element nodes that satisfy certain patterns that is provided in the expression. So XPath is used to return a collection of element nodes that satisfy certain patterns. The names in the XPath expression are nodes, the node names in the XML document tree that are either a tag element or it can be an attribute names, possibly with some additional qualifier conditions to restrict the nodes that satisfies the pattern. So normally XPath consists of the tag name and the attribute name with certain conditions. Now XPath, there are two main separators while specifying an XPath. That is one by using a single slash and second one by using a double slash. What is the difference between these two? A single slash before a tag specifies that the tag must appear as a direct child of the previous tag. If we are having a direct child available, we can use a single slash. The tag must appear as a direct child when we are using a single slash. But if you are using a double slash, it may be anywhere within that parent-child relationship. It may be at the 5th level, or it may be at the 10th level also. It must be a descendant of the previous tag, that's all. But single slash means it must be the next one. But double slash means it may be anywhere within the path starting from the root element. It is customary to include the file name in any XPath query that allows us to specify the local file name or path name that specifies the path. So we should provide the entire path or the file name of the place where we are having the XML documents available. For example, this is the URL slash company. So slash company means it is following a single slash that focuses on company XML document. Now we will see how XML querying can be done by using this XPath method. We will see 5 examples and the meaning of these 5. So meaning is single slash company. The meaning is, so look at here, it returns the company root node and all its descendant nodes. That means it returns the entire XML document if you simply put a query like slash company. Okay. Now the second one is slash company slash department. What is happening there? It returns all department nodes and their descendant subtrees. So under company we are having department. Under department, whatever nodes are available, that will be displayed here. Now third one, we are using a double slash employee with a condition within square bracket employee salary greater than 70,000 slash employee name. What is happening here? It returns all the employee names. It returns all the employee names that are direct children of employee, such that the condition that employee salary is greater than 70,000. So double slash means we are not going into the root, the entire path. So under employee name may not be present directly, but as we are using double slash, from the employee, from any location we can identify the employee salary or employee name at whichever level that value is present. Then fourth one, single slash company employee salary greater than 70,000 employee name. It is this is providing the same result as the previous one, because only thing is here we are using single slash company slash employee. So here we are not providing company, but here company slash employee, this condition, then employee name. That is only difference here. Double slash means directly it will go to employee without referring company. If you are using a slash employee, it is wrong here. Double slash employee means it is keeping company part, but still it will go to the employee and following the elements and conditions given over there. Then fifth one is slash company slash project worker hours greater than or equal to 20. It returns all the project worker that their descendant nodes are children under a path company project. They have a child node hours with value greater than 20.0. So this is the way in which we are writing XPath. Now the second type of XML querying is by using XQuery method. So what is this XQuery method? XQuery uses XPath expressions similar to the previous one, but has some additional constructs. It is almost following the same format, but we are adding some additional constructs also. So XQuery permits the specification of more general queries on one or more XML documents. So it is a generalized format of querying the contents of XML document. So the form of writing XQuery is in FLWR format or FLWR expression. That means 4 let were returned. FLWR, 4 let were returned. So what is this for? 4 is used for binding the variable bindings to individual nodes. For X, for Y, like that. Then let is used for variable bindings to collections of nodes. Let, it is used for binding to more number of nodes, collections of elements. Where is used for qualifier condition, and return is used for query result, what is to be taken as the result, what is to be returned as the result. So for let where returned is the general format of writing an XQuery statement. So we will see 3 examples and how it can be described in XQuery format. So here you can see for $h in. So it's $h is the variable representation in XQuery. For $h in, this is the URL, /. So here we are following XPath again. Employee salary greater than 70,000 / employee name, and it returns result under result tag $h / first name $h / last name. So what is happening here? It will return. So you will see this query retrieves the first and last name of employees who earn more than 70,000. That's all. $h is bound to each employee name element, that is a child of an employee element, but only for employee elements that satisfies the condition of salary greater than 70,000. Okay, now second one, for all H in the document URL /company /employee where $h / employee salary greater than 70,000. So along with condition we are using this bound variable, which returns result $h / employee name / first name, comma $h / employee name / last name. So here also we can use the XPath format. So what is the meaning of the second? This is having the same meaning as in the first query, only difference is the XPath is by using single slash. We need to pass through the entire expression path. Then third one more example we will see for $h in doc the URL /company /project number equal to 3 /project worker, comma $y in. So here we are having 2 bound variable. It is just like a nested concept. Another URL, it is the same URL /company /employee where $h / hours greater than 20 and $y.ssn is equal to $h.ssn. So it is just like a join operation that returns employee name, $y employee name first name, $y employee name last name, and $h hours. Okay, so different 2 relations are being joined. So these are some of the example XQuery which is used for querying the XML database. So that is all for now. So today we were discussing about the second way of making an XML document as valid XML document, that is called as XML schema. We have seen the syntaxes of XML schema, the importance of different tags, elements, the representations, and the different importances of this XML schema document. And in the second part we were discussing about the different querying mechanism for XML databases like XPath and XQuery method. So that's it for now. We will come with a new topic in the next session. Thank you.